Thank you, Mineral Deposit Division of the Geological Association of Canada, for providing us this opportunity to highlight a series of chapters in the GAC Special Paper 52 that pertains to metasomatic mineral system with iron oxide, copper, gold, and affiliated critical metal deposits. Throughout the volume, we discuss and present and illustrate the geological, geochemical, mineralogical, and geophysical footprints of those mineral systems, show how we can use alteration as an exploration vector to mineralization, how we can use geochemistry as exploration tool, and how all that data that we have gathered allowed us to make a very holistic deposit model for those mineral systems. I am Louise Corriveau, and the co-editors of the volume are Eric Potter and Hamid Mohamed. Throughout many of the chapters, we do use the Great Bear Magmatic Zone of Northern Canada as a key field examples of the evolution of the systems and the alteration phases and the metal association that occur in the systems as they evolve. We also use the Nico deposit of the Great Bear as a key case example, but we complement that quite a lot by South Australian example using the Olympic Dam deposit and other deposits of the Olympic Copper Gold Province. We also use Andean, Chinese, and Aran district, as well as Indian district. And together, this provides quite a broad overview of those mineral systems. They form iron oxide apatite, iron oxide apatite rare earth deposits, IOCGs, skarn tungsten, skarn iron, a whole albitite hosted uranium, albitite hosted gold, gold cobalt copper, and a whole series of other deposit types. We also show a lot of new maps for those systems and deposits, including a new map for the Olympic Dam deposit, as well as new insight on the earlier magnetite-rich alteration that occur at Olympic Dam, and that is now in many places replaced by hematite-dominant assemblages. We show through field geology and drill core pictures how siltstones and volcanic rocks totally change their appearance as they are being metasomatized, or the evolution of the alteration phases will make very distinct deposit types. For example, taking a siltstone, transforming it in magnetite and amphibole, or taking an andesite and transforming it into an iron oxide apatite deposit through increasing replacement that we can demonstrate in the field, or through extensive amphibole magnetite bitite alteration, then form gold cobalt bismuth deposits, or as the system evolve, have bitite magnetite alteration that can be also stratabound in sedimentary rocks and form magnetite bitite chalcopyrite IOCG deposits, or evolving to iron oxide breccia with magnetite or hematite infill and replacing fragments and precipitation of chalcopyrite, gold, silver, and it could also be uranium, platinum group element, cobalt, bismuth, and other metals. We also use a lot of geochemistry from the Great Bear, from the Missouri district, and the 10,000 analysis provided by BHP to characterize the Olympic Dam deposit. We can show, using the AIOCG diagram with potassium, sodium versus calcium, iron, manganese, and magnesium and silica, how least altered rocks will consecutively be transformed into totally new rock type. For example, least altered rocks moving in to form albitite or to form skarn, high temperature calcium iron with amphibole magnetite, magnetite dominant, magnetite K-feldspar, K-feldspar dominant and then hematite sericite dominant, and then just hematite and fluorite and hematite and quartz. So using those diagrams, we can also plot the metal endowment and show how much the metal contents will vary according to alteration facies. We also display other geochemical characteristics of the varied deposit types, their geophysics, as well as their mineral chemistry. So we hope that you will be enjoying our GAC Special Paper 52, and would like to really thank the Geological Survey of Canada for giving us a lot of time to produce the volume, edit it, and make the proof, as well as the Mineral Deposit Division, who have sponsored our short course throughout the years and who are now sponsoring greatly the printing of the book and sponsoring this webinar today. Thank you, MDD. We also want to thank the Dene First Nation Mineral Exploration Company for sponsoring our short course and this volume, as well as the GAC IAH Quebec 2019 meeting, who are also sponsoring the book. Finally, thank you, Geological Association of Canada, for publishing it and for providing a fantastic editor to help us complete the book. And thank you to all the reviewers who have done so much work on our paper to make it as good as they are. And finally, the last big thanks to all the authors and co-authors. Without them, the book would not be a reality. And we hope that you will all enjoy it. And thank you very much for your time.